Elements and atoms. All substance, by now we all substance or all matter are made of what we call elements, and those elements cannot be broken down into smaller substances by any chemical means. We usually describe any element by using chemical symbols. So something like carbon, we use the symbol C. Iron, we use the symbol Fe. Elements contain one type of smallest particles that we call them atoms. Those atoms weight is 1.67 multiplied by 10 to the power minus 27. Inside the atoms there is subatomic particles. Those subatomic particles either concentrated in the what we call nucleus or surrounding this nucleus. So any atom contains electrons which are negatively charged that revolving around the nucleus, and we have nucleus which contains protons and neutrons. The protons are positively charged while neutrons are neutral. The mass of the atom is concentrated inside this tiny nucleus. Experiments with subatomic particles. Scientists by the beginning of 19th century, scientists were more interested in studying electricity. And the study of electricity led to the discovery of electrons. They used the cathode tube, where this cathode tube has this high voltage that is connected to a cathode and the anode. When this high voltage is applied, the cathode ejects particles that traveled with a high speed to hit a fluorescent screen. This fluorescent screen lights when it is hit by the beam that ejected from the cathode side. Scientists add magnetic field in the middle of this tube and electric field to see what happens to this beam. They found out when they applied the magnetic field, the ray of that ejected from cathode tube deviated and deflected to point A, while applying the electric field, this beam deflected to point C. From that, that led them to believe that those particles that traveled from cathode, they must be negatively charged because they repelled from the negatively charged plate that is held in the middle of this tube. After the discovery of electrons, scientists started to get more interested in studying the elements and properties of elements, and that led to the discovery of the radioactive elements. Rutherford came and used this one of the radioactive elements that eject alpha particles, and he put it in a lead box and allowed for a small beam of alpha particles to hit a thin gold foil that is surrounded by a fluorescent screen. When the beam of alpha particles passed through the gold foil, most of the ray passed directly through the this gold foil, indicating that most of the atom is an empty space. And some of those deviated or deflected with a wide angle. He believed that those deflected beams are due to that the alpha particles is a positively charged particles, that when it is just came across the electrons, the negatively charged electrons, they deflected. The more interesting part was that some of those rays actually deflected back, and occasionally these alpha particles turned back like they hit something and they just deflected back because they hit this thing. From that he postulated that it must be a positively charged small nucleus that led to the alpha particles to turn it back on the same direction that the emitter emitted those rays. So by that, Rutherford gave his postulation that the atom is actually a very big empty space that contains a nucleus with a positively charged particles and electrons which surround those this nucleus. The further study of the radioactive elements led to the discovery that nucleus doesn't contain only positively charged particles, but they contain as well the neutral particles, which are the neutrons. Let's take a question. A beam of electrons is passing close to a highly negatively charged plate. So now I have a highly negatively charged plate, and a beam of rays passing close to this highly negatively charged plate. When electrons pass close to this plate, they deflect. They bend away from this plate. When the deflection, what deflection would you expect if we repeated this experiment using a beam of protons and a beam of neutrons? Of course, if I repeat this experiment using a beam of protons, so they will be deflecting, the beam would be deflected towards the negatively charged plate, while for neutrons, they will not be deflected. Will not be affected by the presence of the charged plate. Second, which subatomic particles, electrons, protons, or neutrons, would be deviating the most? So, if I have the three particles are deflecting, the proton are deflecting and electrons are deflecting, which one of them is deflecting more? So the deviation would be most with the electrons because they are lighter. Subatomic particles, masses, and the charges. In this table, we could see that the subatomic particles are electrons, neutrons, and the proton symbols are E, N, and P. The relative mass of them almost the same. The neutrons and the protons have the same relative mass, but the mass of the electrons is very small comparing to neutrons and protons. The relative charge for the electrons are negative, neutron is 0 because they are neutral, and protons are positive 1. There is what we call the number of protons. We name them Z, and this number of protons is actually called atomic number. The number of proton the atomic number is equal to the number of electrons in neutral atom. As for the number of nucleons, the particles inside the nucleus, number of nucleons, we give it the symbol A. Is the number of protons plus the number of neutrons. If we want to know the number of neutrons, we can subtract the number of nucleons minus the number of protons to give me the number of neutrons. Example: use the information given to deduce the number of electrons and neutrons in the neutral atom. Vanadium with nucleons number equal to 51 and the proton number equal 23. So if this is the number of nucleons, the mass number that we give it the symbol A is actually the number of protons plus neutrons, and this one is the number of protons. So the number of electrons would be equal the number of protons in a neutral atom. As for the number of neutrons, it would be equal to the number of nucleons, the protons and the neutrons, 51 minus 23, which is equal to 28. So I have to remember this is the Z, the atomic mass, and this is the A, which is the atomic mass. Isotopes. Isotopes are the atoms of the same element that have the same number of protons and a different number of neutrons, or different nucleons numbers, which is A. Isotopes have the same chemical properties because they have the same electrons number. So what are isotopes? Isotopes, something that have the same number of protons. If I looked at carbon 13 and the carbon 12, they have the same number of protons, which is 6. Both of them have 6 electrons, and they have different number of neutrons. The same chemical properties, but because they have different nucleon number, they will have different physical properties, such as a small difference in density. Writing chemical symbols for isotopes. Isotopes either is written as hydrogen. For here we have example, hydrogen has 3 isotopes. Either it is written as hydrogen 1 or hydrogen 2 or hydrogen 3. According to the number of the neutrons, or we can write it as a symbol. We symbol the symbol of hydrogen H, which is H, and the atomic mass on the top and the atomic number on the bottom left hand side of that symbol. I have for hydrogen 1, this means I have 1 proton and 1 neutron, which is the protium, and for hydrogen 2, this means I have 1 proton, 1 neutron and 1 electron, and we name it deuterium. For hydrogen 3, it contains it have 2 neutrons and 1 proton and 1 electron, and the name is tritium. Example: write isotopic symbols for the following neutral atoms: bromine 81 and calcium 20. For bromine, the symbol would be Br, B capital, and R is lowercase, written in lowercase, and the 81 is written in the on the top of the left hand side, and the number of protons would be written down, which is 35. Calcium is Ca with 44 on the top and 20 written down for the number of protons. How many protons, neutrons and electrons are there in ions? So the number of protons are equal to the number of electrons, like we said before. Z would be equal to the number of protons and equal to the number of electrons. This happens in neutral atom. But what happens if I lost or gain the atom lost or gain electrons? This would change the atom into what we call ions. Example for that: chlorine atom, it usually gains 1 electron, and it transfer by that into chloride ion. The chlorine atom contains 17 protons and 17 electrons because it is neutral atom. When it gains 1 electron, this means the 17 proton would remain the same, but the number of electrons would increase by 1, so it will have 18 electrons. So the chloride ion has a single negative charge written on the top here due to the presence of one extra electron that is gained by the atom that converts this atom into ion. Another example, magnesium atom usually loses 2 electrons and transfer into magnesium ion. The number of protons in magnesium are 12 protons and 12 electrons. The losing the 2 electrons transfer magnesium into magnesium ion with 12 protons. The number of protons remains the same, but now we have to subtract 2 from the 12 to have 10 electrons because it lost these 2 electrons. Another example, reduce the number of electrons in each of these ions. Potassium 1419 and nitrogen 15.7. First, if I looked at the number of electrons in neutral atom should be 19, and in that case would be 7. So let's first find the number of electrons in case of potassium positive. This means I have in neutral atom here I have 19, but because I have already lost 1 electron, this means the 19 minus 1, which is equal to 18 electrons. So I have in potassium ion I have 18 electrons. The number of electrons for nitrogen is minus 3. This means the in neutral atom, which is 7, is has gained another 3 electrons that make the total number of electrons equal 10 electrons. My next video would be on chapter 3. Thank you and goodbye.